Hello everyone and welcome to VitoshAcademy. Today we'll be solving the frog jumping puzzle here with depth first search and Python and Jupyter notebook. And just let me show you how this puzzle looks like and what does it do. You can do two things with these frogs here. You can either move to the left one or you can jump over the other one. The problem with this puzzle is that the frogs, once they move, they cannot return. So it's rather complicated. As you see already, the frogs are stuck. So try again. And of course, we'll be doing this with Python and with Jupyter notebook here. So we will not be having frogs. We'll be having something else. So what are we going to have? Let me show immediately. This would be our left frog. This would be our right frog, and this would be the empty stone. So the start state would look like this. You see 3 to the left, facing left like here, and then 3 to the right, facing right like the other one, and then the go state would be looking exactly the way it should be looking like. Okay, so we actually have 4 legal moves. As I already mentioned, you can either move this one to the empty, this one to the empty, or like this one to the empty, this one to the empty. You can jump from the left or you can jump from the right, nothing else. 4 legal moves. So that's all we're gonna do. And in order to generate these moves, we need to think, how do we do it with Python? I already have prepared something and I'll just copy and put it to you so you don't waste time. It looks like this. Let me show it to you. So it's called neighbors research. So if we have the left one, something that we don't know, and an empty place, it is just returned to empty place because this one has already jumped. Something we don't know, and the result. And correspondingly the same for the right one, jumping this way. And if we only have to make a step, it is like a frog and then empty place, and the result is empty place and a frog. I can probably use equal sign here so it is more understandable what exactly is happening. Something like this. And then the last move that we have would be like that. Okay, so let's see the neighbors research. How does it look? Neighbors research, and we give the state. This is the state that we're gonna say give. So the neighbors research simply returned 4 states. So the first one is something has happened. It's obviously the big jump, like from it has appeared here. So this one, the second frog jumped into here. Let me show it to you here. Reset puzzle. This is the state. Yes. This one is pretty much the same, but from the other side, the third one is just a tiny step. And this one is a tiny step from the other side. Yeah, fair enough. Everything is quite okay. Now let's think, what do we do? Well, I'll call this one. So I will call it solve frogs with DFS, and we get an N. Why do we get an N? Well, pretty much I'm just going to call it like this. So frogs with DFS, let's start first with 2, and it's gonna return something. So we need a start, and for the start we'll be using the start state like this, of course, the N. And for the go, we'll be using the go state, and it will be returning N. Then the visited would be a set, an empty one. The idea is that whenever we have something like this, we should be returning it. We should be remembering it, not returning, but remembering. And this way we'll never go into a loop once we have visited something. So we'll be happy with this. And then we have the path, and the path will be just a list. And now the magic, how would the magic look like? The magic is actually really simple. It would be like a function within a function. So this way, these ones here would be something like global variables. Of course, they wouldn't be global because this is a bad practice, but they would be function wise. Global, they would be global for the DFS function. So the state, okay, I'll say that it is string, and it would be returning a bool. That's important. I mean, usually I don't write here what the state is, what it does return, but in this case, we'll do it. So first, let's see if the state is invisited. We want to drop it immediately. Yes. And then visit it, adding the state. And we append to the path. Path.append is what we need, appending the state as well. So, and if state equals go, return true. Yes. And what else? Now the tricky part for next state in neighbor research, pretty much this one. And we are giving the state. And here we say if DFS next state, if it is true, so to say this one, then return true. Pretty much. And it says if the state is the go for it here, then return true. Else pretty much not a lot. And then if nothing happens, we remove the path and we return false here. Okay, fair enough. DFS start. This is the end of the function. So after the function, it happens like this, and we return the path. And actually, it will work. Even with the two, you see immediately it says the first move is this one, the second move in this one jumps to here. From here, we have this one jumping, or this one more like moving. It's not a jump, it's just a move. And after this move, something else happens. Pretty much this one goes here, obviously, and it leaves its place. Then the first one obviously has made a jump. Then the second one has moved to the left, and so on. So what is more important is not simply to see this and to say, hey, I'm really clever, I found some code and I managed to explain it. No, the idea is to present it a bit better. So how can we present this code to someone who doesn't understand a lot, but still has some idea about Python and Jupyter Notebook? Let's start printing stuff. Print currently visited states. And here we'll have a variable saying len visited, and of course +1 because we need it. Let me see why. Because I don't want to start with 0, although programmers usually start with 0. Okay, yeah. So what happens here is somehow we found out that 34 times we have run through this place here. We can do it somehow else. Let's see. We can put a step here and we can say, okay, I want to make sure that I know what's going on. And this way, for example, we can see the state and the visited set, and probably it will start running one by one and increasing. Oh, just sorry. Yeah. Nope. This one, nope. Then this one, co-stack, and the visited set will be here, just showing up. Yeah, this is actually useful at the beginning because it's okay, but at the end you can probably have some problems to understand where exactly you're finding yourself. Let's run once more just to see the visited set. Yeah, just quite a lot of them, and it's actually interesting this way. Yeah. Property inspector, I mean, just Jupyter notebook is actually interesting. We can see here everything, just opening a parent information, but we are not going to do it this way. We want to be presenting the whole thing. We want to understand how it works. So let's continue. How do we remove this one? Okay, now it is removed. How do we continue? Let's print the edit state somewhere here. Visited at path append, and here we say print f state, and we will have edit state like this, a new line, and we got the edit state. Pretty much every time we add a state, we have an information about it. And all 22 times or 34 times we understand which one we are adding. But to get the point, we don't only need to know which one we are adding, we need to know which one are we popping, just to get some idea. So for the popping, I have prepared something nice. Something like this. Okay, dead end found, and then new line, and we print the last one in the pop, and path so far last is removed. And of course we need print path and path, and most probably it would make sense to put this one here. If you want to know what's a print path, that's a good question. Let's declare it somewhere. Probably I'll put it somewhere here actually. Def, it should be really easy. Think print path. And of course we don't need an n, but a path here, and it's just a loop. So for row in path, pretty much print row. Simple as this one. Let's see how it will work. Okay. Do we got something? Okay. We got a dead end found, which is a bit unfair. Another dead end found. You see that the first one, this is obviously a dead end. What has happened is after just a few movements, most probably we got a jump and then a move to the left, and this is how we got this dead end. Pretty much we got this and then that, and of course that's a dead end. Another dead end found, we simply got this, and then after this we probably got this one, but it wasn't a dead end. But yeah, it's interesting. Doesn't look like a dead end to me, but probably the next one is a dead end, so yeah, should be. Or this -1 is actually not useful. Let's see. Yeah, Exactly. Dead end found. Is it where the mistake happens? Yeah. Okay, so it is useful. It is actually. Print path. Okay, we should be printing this one. And it should look like this. Okay, so dead end found. This is obviously a dead end. This is obviously one before a dead end, but let's run it. Yeah, one before a dead end. Somehow it also considers it a dead end because yeah, obviously if it only has one and the one is also with a dead end, then it happens like that actually. But so far the last is removed. Okay, now I got it. But so far the last is removed. Print path. Okay, we can do it actually like this. And now I'm going to explain everything. Yes. So, but so far the last is removed, and it is a dead end because this one here exactly is a result of this one. That's why we have a dead end. This one here is the result of this one. That's why it is a dead end. So this is why we get a dead end. And at the end, for example, here it's obvious dead end. Here it is obvious, not obvious dead end, but this one here is the result of this one here. So I hope you got my point. I mean, the calculation is tough, so that's why I meant we had to explain it. We had to know what's going on. And just to make it a bit more interesting, let's add something here. Ta-da. Dead end found, removed, pop. And at the end, I'll just prepare something up before returning, just make it beautiful. Okay, so let's give it a try. So we found a dead end here, but we continued. We found a dead end here, we continued, and at the end it looks actually okay. After we find a dead end, it's a DFS, we just remove the previous one and we continue with whatever we have left in our neighbor's research. I'm just interested whether at the end we can run it and take a look in the whole thing. Let's give it a try. Reset puzzle. Okay, so this one is the middle, then obviously the third one is move. Okay, this one is moved, then this one is moved, then the fourth one is moved, the second one is moved, I'm already here, and then the first one is moved, the third one is moved, here it's fifth one is moved, and then the last one is moved, and we are here. And then we continue with the pre-last. Then we have another jump here, and then another jump here. And I already know what to do. Yes, we solved the puzzle. I mean, so far so good. I hope you enjoyed the video. 20 plus minutes of it. And yeah, like and subscribe. Enjoy the rest of your day. Take care of yourself. Goodbye.